Okay, so let's continue our discussion on work and energy. This time, we're going to talk about power and efficiency. Okay, so but first, no, let's have a quick recap of what we have discussed last time. So last time we've discussed on the on the variable forces, okay, and then also we have this constant forces no, in rectilinear translation. So from those concept of work, okay, and energy, we will use that on power and efficiency. Okay, so now let's define what is power. Okay, power is the time rate at which work is done on a body. Okay, example, if a train is uh, being pulled by a locomotive, the work done on the train may be measured by the work done by the drawbar pull. Okay, so in short, power is work over time. Okay, or what we call the average power. Okay, they're calling it average power. So work during any instant is summation of x. So this is work times ds, and this is F is equal to F ds. Okay, where F is net force doing the work. So therefore, yung power exerted at any instant is work over time is equal to force times ds over dt, and we know that this ds over dt is velocity. Okay, the change in displacement over the change in time. So when it comes to work, okay, so these are the formulas that we need to memorize or appreciate, no? So again, power is the time rate at which done on the body. So saan nanggaling yung power in work and time? So that is the ratio of work over time. Okay? So if we are talking of power, we're also talking about efficiency. Efficiency is the ratio of power output over the power input. So efficiency, or in Greek, this is Greek sign eta, yung parang letter N na mahaba. Okay? That is power output over power input times 100%. Okay? That is for efficiency. So units is pwede siyang watt, no? That is 1 Newton meter per second. Sabi nga natin, that is work over time. Pero, okay, pwede rin naman siyang 1 joule per second kasi ang 1 Newton meter is joule, di ba? This is work, no? Force times distance, Newton times meter. Okay? Pwede rin naman siyang in terms of horsepower. Ito, HP is 1 horsepower. Yan. That is equal to 746 watts or 746 Newton meter per second. Pwede rin naman yung ating 1 horsepower is in terms of naka-English system siya. So that is 550 pounds foot per second, or pwede rin 33,000 pounds foot per minute. Okay? So that is 1 horsepower. Okay? So to apply this, no, itong mga napag-usapan natin on power and efficiency, let's solve this problem. Yan. States here that a train weighing 100 tons is being pulled by a 2% grade. The train resistance is constant at 10 pounds per ton. The speed of the train increased from 20 feet per second to 40 feet per second in a distance of 1,000 feet. Find the maximum horsepower developed by the locomotive or yung ating machines, no? Nahihila dun sa ating train. So to solve this one, we have to remember yung ating work equation or work energy, that is summation of x ds is F ds. Okay? So we know that work or net force came from the what? Inertia force. Okay? That is from this, in this case, mukhang ang equation na gagamitin natin is summation of x times s is equal to w over 2g times v squared final minus v squared initial. Remember, we're using still the work energy equation. So if that's the case, now let's solve this problem. For our solution, okay, so ano yung mga unknown sa problem? We are asked to find the power, but to solve that, we have to find the force that is needed to have power. Okay? So that is yung F. Ito yung unknown natin. Okay? We are given, no, yung ating train weight na 100 tons. Okay? Ano pa? Pinupull daw siya at to 2% grade. What else? We also have the, okay, meron pa dito nakalagay, no? Yan. Okay, so meron tayong 1,000 feet na distance. So parang mukhang displacement, no? 1,000 feet. Ano pa yung mga nakalagay dito? Meron tayong, ayan, okay? Meron tayong mga velocity, no? V sub final is 40 feet per second stated in the problem, ayan. And then initial is 20 feet per second. Parang nag-increase daw from 20 to 40. Ayan nakalagay sa problem. Okay? So, initial natin is 20 feet per second. Okay? So, ano pa yung mga given sa problem? Meron tayo dito nakalagay, sabi sa kanya is, balikan natin yung problem. Nakalagay sa problem is, a train weighing 100 tons is being pulled by a 2%, is being pulled by a 2% grade. The train resistance, o yung resistance natin, parang lumalabas friction siya, is 10 pounds per ton. No? Or, ano to, parang lumalabas na, parang ano siya, weight over weight, parang gano'n, no? Train resistance. So, lalabas, ito ay ano, parang ito yung ating coefficient of friction, parang lumalabas na gano'n. No? So, kung yan yon, edi meron tayong parang lumalabas na 10 pounds per ton na resistance. Okay? 10 pounds per ton na resistance. To solve, no? So apply na natin yung ating summation of x times s is equal to w over 2g multiplied by v squared final minus v squared initial. So that is f minus 100 times 10, okay? Minus 100 times 2,000, yan, okay? Times yung ating slope na 2 over 100 kasi 2% no, nakalagay yung ating grade. Okay? And this will be multiplied by 1,000 feet na displacement. Yan. Equal siya sa 100 times 2,000. Okay? Saan nagagaling yung 2,000 na yon? Yung W na weight. Okay? That is equal sa nakalagay. Kasi tons yung ano natin. So, para ma-convert into pounds. Yan, no? Conversion to. This is our conversion factor. Ito. Yan, 2,000 na to. Ito yung ating mga conversion factors. No? Yan. Baka mabigla, no? So, ito, W over 2G. So, 2 times 32.2 pounds per feet squared. Tapos, multiplied by the final velocity, 40 squared minus 20 squared. So, therefore, yung ating F will be equal to 8,726.708,075 pounds. Ito yung power, ito yung force na kailangan natin to have a certain power na need sa problem. Okay? So, to compute for power, okay, so dito na lang, anong ulit yung F natin? Ang na-compute nating force is 8,726.708,075 pounds. So, our power is force times velocity. Okay? So, power is, yung ating force, ito, yan, 8,726.708,075. At yung ating velocity is yung final, times 4 feet per second. Okay? 40 feet per second, ito yung pounds. Therefore, yung power natin ay equal sa 349,068.323. This is pound foot per second. Or kung i-convert natin siya into horsepower, ano nga ulit ang mga unit, no? Para ma-convert daw yon, yung 1 HP is 550 pounds foot per second. So, lalabas, kung i-convert natin to, parang ito ay di-divide natin sa 550 pounds foot per second para maging yung power natin ay equal na sa horsepower. Okay? So that will be equal to Yan, 634.6696781 horsepower. And this is our answer. Okay? Ngayon, pag binigay sa problem na converted into watts, okay? So, alam natin yung variable, no? Or mga conversion factor doon. Okay? So, this is our answer for the first problem. 634.67, no? Kung i-round off, horsepower. Or that is 349,068.32 pounds-foot per second. Okay? So, that is our answer for our first problem. Now, let's solve for the second problem. States here that water flows through a nozzle 1 inch in diameter under a head of 4,000 feet to drive a turbine. The turbine is 90% efficient and is connected to a generator which is 94% efficient. What is the power output in kilowatts? Okay. So, to have this problem answered, we must first understand the concept of power sa area of fluid mechanics. Okay? So, in fluid mechanics, power is gamma times Q times the height. Okay? Q here is discharge. Okay? This is equal to cubic meter per second. Okay? Pwede rin cubic foot per second. And Q is also equal to area times the velocity. So, area is in square meter per second. Okay, so ito is square meter. Sorry. Velocity is pwedeng meter per second. Yan, pwede ring feet per second. And so on. Gamma is the unit weight of water or unit weight of liquid. Okay. So, usually, ang mga gamma is in terms of Newton. Yan. Pwede rin kilonewton. Okay. Pwede rin pounds. Yan. Okay. And then yung height, yung ating, ito yung ating head. Okay, or energy head. Okay. So that is power in fluid mechanics or in hydraulics. Okay. So if that's the case of power, so we could solve power output here in this problem. So to solve that, we must first understand, just like I said, no? Ito, dadalhin natin yung P is equal to gamma QH. Okay? So, this gamma QH is equal also to force times the velocity. Diba yun yung power natin? Okay? And that power, just like I've said, this is gamma. Okay? Q is area times velocity times height is equal to F times V. Ito rin yung power. Okay? So, pwede natin nang ma-solve, no? Therefore, yung ating force pala, okay, is equal pala siya sa, kung pag-iwalay natin to, canceling out velocity, tama ba? Lalabas yung ating force ay equal sa gamma AH. Okay? So, that is equal sa, kung ang sabi sa problem ay water, at binigyan tayo ng mga feet, inches, so meron tayong two options to do that. Pwede natin gawin na naka-English tayo. That means, yung ating mga units ay in English, pwede rin naman naka-metric. Okay? Ang ating gamma, okay, gamma natin sa English ay naka-pounds per cubic foot. Sa metric is naka-newton per cubic meter. Okay? So, sa English, that is 64 pounds per cubic foot. Sa metric is 9,810 Newton per cubic meter. Pero dahil binigyan tayo ng mga units na naka-English, so, English system ang gagamitin natin. That is gamma, 62.4 pounds per cubic foot, multiplied by the area. Ano ang area nakalagay dito? Sinabi dito na, ang gagamitin natin ay nozzle, ibig sabihin, circular, no? Pag nozzle, circular yung kanyang section. So, meron tayong diameter given. Okay? So, ang area ng ganitong section, so, meron pa yan, di ba, wall thickness, pero ang kinoconsider natin yung kabuuan. Area is pi d squared or pi r squared or pi d squared over 4. So, gamitin natin yun yung area. So, the area is pi d squared. So, that is pi over 4 times d squared. Ano yung d squared natin? 1 inch. So, that is 1 over 12 squared. Now, this is, lalabas na to, feet squared na to. Dahil, yung inches kinonvert natin sa feet. Times the head. Now, sinabi sa atin na yung h or yung head natin is 400 feet. Ayan, nakalagay sa problem. 400 feet. Okay? Times 400. So, therefore, our force is equal to 136.1356817 pounds. Okay? That is the force. No? Ngayon, in this problem, no? Remember our formula, no, ng ating kinetic energy. Anong ulit ang ating kinetic energy? Kinetic energy, okay, is equal to 1/2 V squared over G. Okay? And we know that this kinetic energy, if this is in fluid, no, magiging 0 na to. This will be equal to 0. Parang equating to 0 dahil equilibrium, no, in equilibrium. Therefore, our velocity coming from the kinetic energy formula will be equal to, or using the Bernoulli's energy equation, no, doon din siya galing, no, Bernoulli's energy equation. So, from Bernoulli's energy equation, yan, doon manggagaling yung equation na gagamitin natin for the velocity. Okay? That will be equal to, velocity is equal to square root of 2gh. Okay? Saan galing? Sa Bernoulli's energy equation. Okay? Okay, ito yon, no? Ito yung ating equation, no? Bernoulli's energy equation. That is, from Bernoulli's equation, that is kinetic energy, okay, is equal to potential energy. Ito. Okay? So, that's Bernoulli's energy equation. So, kung ito yung ating velocity is equal to 2 times 32.2 times the head na 400. Therefore, ang ating velocity sa nozzle, no, is equal to 160.4992212. This is feet per second. Yan. Meron na tayong velocity, meron na rin tayong force, no? Actually, this formula applied sa nozzle, no? Ito yung kanilang mga formula. Velocity in nozzle. By the way, nozzle is a measuring device, no? Nozzle is a measuring device for fluid. Okay? Measuring device to for fluid. Ayan. So, para malaman natin, anong sinusuot sa nozzle? No, pwedeng velocity, pwede rin yung ating discharge or yung ating yung discharge na Q. No? Pwedeng yun ang ating sinusolve. O yung volume, velocity per time. Pwede rin volume per time pala. Volume per time or discharge. Okay? So, ito yon. Diba? So, nozzle. So, meron na tayong F, meron na tayong velocity. Ayan, meron tayong velocity. We could actually compute for the power, no? The power that we're going to compute here, based sa problem at pagkakalatag ng problem, is what we call the power input, no? Ang masasolve natin muna is yung power input. That is equal to force na nakompute natin times the velocity. Saan ang galing to? Dun sa nozzle, no? Bakit? Kasi yun yung papasok pa lang, no, based sa problem, balikan natin. Mukhang papasok pa lang siya dun sa nozzle and then magdadrive daw sa turbine. Okay? Tapos dadaan sa generator. Parang lumalabas, ganito ang setup niya. I-drawing natin. So, lalabas, ganito ang setup. May nozzle dito. Ito yung nozzle. Let's say yan. Tapos, bilang dadaan siya sa turbine, tapos nakakonect din siya dito sa, anong sinabi sa problem? Mukhang nakakonect sa generator. Ito. Okay? Ayan. Tapos may lalabas diyan, no? O, pwede ng power na 'yan. So, ibig sabihin, may papasok dito na fluid, okay? Tapos dadaan sa turbine, then mako-convert into power. So, therefore, itong kinocompute na to ay yung ating power input at yung lalabas dito ay ating power output. So, ang kinocompute pa lang natin is yung power input dito saan? Sa nozzle. Okay? So, our power input or P sub I is equal to force na na-compute natin. Ito, that is 136.136. Yun na lang muna. Lalagay ko for the sake of calculation. 136 times 136 multiplied by velocity. Our velocity na na-compute is 160.449. Yan. 0.449. So, be mindful of the units ang ginamit natin sa force ay pounds at yung sa ating velocity ay feet per second. Okay, lagay natin. So, ginamit natin dito ay pounds, dito ay feet per second. So, our unit ng ating power or power input, yan. Ang unit natin will be equal to, yan na. So, naka-pounds foot per second. Or pwede rin naman din natin idiretso ng horsepower. Okay? Saan natin multiply? Parang alam natin na 1 horsepower is equal to 550 pounds foot yan, per second. Para diretso na. Okay? So, our power input in terms of horsepower is 339.72667434. Or they call it, no, ito ay horsepower. Or some of the reference, tawag nila dito ay water jet or jet. Okay? Dahil nga mabilis, ito, katulad ito, para magpo-flow dyan, tapos tatama sa dadaan ng turbine. That is our power input. Ngayon, ang hinahanap kasi sa atin sa problem ay power output. Pero binigyan tayo ng efficiency, tama? Efficiency ng turbine is 90%, while the efficiency ng generator 94%. Lagay natin. For the efficiency ng turbine, ito na lang sa gilid, eta ng turbine is 90%, while the eta efficiency ng generator is 94%. Ayan. Okay? So, itong symbol na to is, this is efficiency. Okay? Or what we call eta, Greek letter eta. Okay? So, coming from the formula ng efficiency, so, eta is equal to power output over power input. Okay? Given sa atin yung generator or sa turbine muna. So, lalabas 0.9 is equal to power output P sub O over P sub I. This is for, remember, this is for our turbine. Yan, yung dadaan sa turbine. Okay? So, kung dadaan siya sa turbine, therefore, ang power output natin para sa turbine will be equal to 0.9 times yung power input natin na 39.726, yan, 6, blah, blah, yan, HP, no, dire-diretso. Therefore, our power output sa turbine is equal to 35.754,00691 horsepower. This is for turbine. Okay, power output ng ating turbine. Yan. Okay? That is our power output for turbine. Now, dahil tapos na tayo sa setup na ito, ibig sabihin, from nozzle, ito, papunta dito, yan. Yan. Okay na, no? Meron tayong power input, meron tayo ditong power output para sa turbine na magiging power input natin papunta sa ating generator. Okay, so ito yung panibagong leg na naman or parang case, no? So, hinanap sa atin ay yung power output para sa generator. So, balikan natin ulit yung ating efficiency. Our efficiency for generator is 94%. So, efficiency for generator, that is power output over power input. Yung power output natin dito is power input from what? From our ating power output P sub O from generator na. Yan. And then yung power input natin, this is power output from turbine. Okay? Ano nga ulit yun? Yun yung ating na-compute na 35.7540069 ito. 35.7540069 horsepower. So, that is 0.94 is equal to power output yung hinahanap natin over 35.7540069 horsepower. So, our power input, or sorry, power output for the generator, remember this is for the generator, okay, generator, is equal to, yan, lalabas na 33.60876649 horsepower. Okay? Ang pinapahanap sa atin is in kilowatts. So, power output, para ma-convert, alam natin na ang 1 HP is equal to, balik tayo doon, sa ating unknown. Yan. 1 HP is 746 watts. Yan. So, 746 yan. Watts. Tapos, i-divide na lang natin, yung mako-compute na watts, sabihin ito, i-divide natin sa 746, tama ba? Or multiply natin sa 746, pero, ano lalabas? Parang ito, lalabas ito times natin sa 746, pero di-divide natin sa 1,000 para maging kilowatts. So, our answer is 25.072138 kilowatts. Ito na yung sagot natin for this problem. Okay? So, ayan. So, medyo masalimhuot dahil dumaan tayo sa dalawang setup. Let's have a quick review of that. Dumaan tayo sa dalawang setup dahil ang sinabi sa atin sa problem, from nozzle, dadaan ng turbine at dadaan ng generator. Remember, meron tayong tinatawag na head or head loss dito sa setup na to wherein 400 feet yung binigay. And from that, nako-compute na natin yung power. At yung power formula para doon is yung power formula from our fluid mechanics or hydraulics. Yan. Gamma Q times the head or head loss. Okay? So that is our solution. And then, from here, yan. Yun nga, dumaan tayo sa dalawang setup. Yung, may para tayong power input from the nozzle na naging meron din tayong makakompute na power output na lalabas sa turbine. Pero, that power output will be power input para sa ating generator. So, kaya ganito yung naging solution natin up until ma-solve natin yung ating power output. This is power output for the generator. Yan. Okay? So, titingin natin sa atin in kilos. Actually, na-compute natin kung horsepower, ito, 33.608,76649 horsepower. Okay? So, that is our solution for our problem in terms of our discussion or in relation to our discussion na power and efficiency.